Okay. So hi everyone, my name is, as I said, Marcos Serrano. I'm an assistant professor at the University of Toulouse, and today I want to present the work that I carried in collaboration with my colleagues Emmanuel Dubois and Mathieu Raynal. And basically our goal is to allow rapid command selection in toolbars, and for this we propose a novel technique that we call rolling menu because it's based on using roll gestures with a rolling mouse. So the usual interaction with toolbars is carried with the mouse through a classical pointing gesture. It requires the user to move the mouse pointer from the object of interest, which will be the text in a text editor, or the drawing area in a graphic design application, to the toolbar. This is what we call, This is what we call the object to command transition, and then come back once the command is selected to pursue the main task, which will be called command to object transition. And actually the true cost of any command selection should include both the movement to the menu, but also the movement back to the main task, which is something that is often neglected. The reason why we should consider both transitions is because they have the disadvantage that they tend to break the interaction flow, as we have to perform multiple object to command transitions. So the most common approach to minimize this object to command transition is to bring the menu closer to the object of interest by using contextual menus. So contextual menus can take different forms, from linear menus to circular or pie menus, but they all share the same fundamental limitations, is that they only include a subset of the menus, and then they are context dependent, which means that the menu items will vary or change for each invocation. So another approach is to add degrees of freedom to the traditional mouse to extend its command selection capabilities while still preserving the normal pointing interaction. And so far, two main approaches have been used to add degrees of freedom to any regular mouse. So the first approach consists in combining a regular mouse with other input modalities through device composition. This is the case of the lens mouse, where a regular mouse was extended using a touchscreen. The second approach will consist in modifying the shape of the mouse to allow supplemental physical manipulations. This is what was done initially in the rocking mouse, and what also we did more recently in the Roly-Poly Mouse, which is a mouse that was developed in our research group. However, to our knowledge, none of this previous work on multi-DoF mice has evaluated a solution for shortening this object to command transition on toolbars. So for this reason, we decided to study this concept, and we propose a novel technique which is called rolling menu, which is a new technique for selecting a toolbar item with a roll gesture using the Roly-Poly Mouse. So the Roly-Poly Mouse is a multidimensional hemispherical mouse that you can see here, which can be, I'm sorry, I don't know why the animations are playing along, but okay. Multidimensional hemispherical mouse that can be translated, rotated, and rolled. So translations are already used to control the application pointer. So for this reason, we use the roll, and basically using the rolling menu to select a toolbar item relies on the activation of a quasi-mode. So a quasi-mode is a specific mode of the application which ends automatically once the selection is performed. And this quasi-mode is activated when the mouse roll amplitude reaches a predefined threshold. So rolling the device is going to activate this quasi-mode, and then we can select the toolbar items. So I'm going to show you a short video which illustrates the concept. You can see here that as the roll of the device reaches the threshold, activates the menu, and then we can select a toolbar item. So in this paper, we limit our exploration to horizontal toolbars positioned on top of the window, which is similar to most application toolbars. And more specifically, we explore three variants of such horizontal toolbars. First, simple toolbars. This is a one-level menu with up to 14 items. And then two types of multi-level toolbars with 8 first-level items and 8 sub-items. So the first type is the dropdown toolbar, which basically consists in a toolbar where each top-level item opens a drop-down list. And the second type of multi-level toolbar that we explore is a grid toolbar, where each top-level item consists in a 3x3 grid, and we didn't use the item in the center. So to use this, to select any item on those toolbars, well, we have to we have to employ, or we have to take profit of the roll gesture parameters, which are basically the direction and the amplitude. So the direction is from a top-down point of view on the Roly-Poly mouse, the direction in which the user tilts the device. While the roll amplitude is from a side view, the inclination angle of the device once it has been rolled. I'm sorry if sometimes the slides change a bit fast because the animation is playing automatically, and it's not my laptop, so sorry. So then the general principle to use these roll parameters to select an item on the toolbar is that once the quasi-mode or the menu is activated, the application pointer is frozen, the mouse pointer is frozen. So it stays in the area of interest. And then the toolbar is associated to a range of possible rolls. And this range is divided into sectors so that each top-level item is associated to one distinct sector. And to select an item, the user rolls the Roly-Poly mouse in the direction of the corresponding sector. So this has two major benefits. First is that we are decoupling the menu selection from the mouse pointer, which, as I said, is going to stay near the object of interest or near the task. And another advantage that we didn't really explore in this work is that it may also benefit from muscle memory, because we are always going to perform the same gesture to select the same item. So again, it's a similar video, but you can see that as soon as the device reaches a threshold, which here it's 12 degrees, the menu is activated, and then the roll direction is going to change the selected sector. Okay, so this is the general principle. So then, starting with this initial idea, we explored several design dimensions, and I'm going to give just an overview in this presentation. All the details are in the paper, but basically we try to answer three questions. First, what's the best method to activate the menu? Then what's the best method to validate an item that is selected? And finally, what's the best mapping between the roll direction and the toolbar? So concerning the activations, we consider two different options, which basically are two different variants of where do we put the activation threshold. So we first consider a low threshold. This is what we call bottom activation. The idea being that we want to avoid unintended activations, and 12 degrees is the minimal limit. And so as soon as the roll goes beyond 12 degrees, the menu is activated. The other idea was to require a larger roll. So empirically, we found that 37 degrees was fine. The reason is that the longer or the higher the threshold, the arc is also longer, so the selection is going to be easier. And so here, the user needs to go beyond this 37 degrees threshold to activate the menu. So once the menu is activated, you need to validate the selection. Here again, we consider two options. Yeah. Okay, the laptop is frozen, but I'm going to continue speaking. So we consider two options. First, a tap. So basically a tap on the underlying surface, as you saw in the video, and then doing a roll. So why a roll? Because the idea is that maybe doing a roll is more fluid, as you're already using the roll to activate the menu. You could also use the roll to validate. I'm sorry, but I think I have to relaunch my PowerPoint. So the short story is that this is not my laptop because it wasn't working with the projection. So. Yeah, it's totally frozen. Yeah. Do you have any shortcut for? Okay, So, as I said, we have tap or roll, but obviously the roll is going to change according to the type of activation that we did. If we did the activation with the low threshold, we still have room to do a further roll. So then we can add a validation threshold that is higher. So as soon as we reach this validation threshold, the item is selected. But if we did the top activation, the one with the high threshold, we cannot go farther because we're already in a very long roll. So the idea is to go backwards. Yeah, to go backward. In this case, the overall gesture to select a menu will be to do a roll forward to activate the menu, or roll backward to select the menu. Then the last question was how to map this roll direction to the toolbar items. And obviously, what I showed before, the idea is that we do a direct mapping. So you roll in the direction, and the direction is going to correspond to the item that is selected. This is what we call the direct range. But this has the disadvantage that the sectors are not going to have the same size, and in this example, for instance, selecting the item that corresponds to the sector A1 is going to be more difficult than selecting the sector that corresponds to the item A3. So we decided to explore other options. So we tried several options, but I'm going to just give you the two that we kept at the end. The other idea is to maximize the size, so we go up to 180 degrees range. We didn't go beyond -90 or +90 because it seemed awkward to do a roll backward to select an item that is on top of the display. And here has the advantage that the sectors have the same size. But we kind of lose the directness of the previous solution because the item selected is not necessarily going to correspond to the direction of the roll. So if I sum up the design dimensions, we have two activation methods, the low threshold, the high threshold, two validation mechanisms, tap or roll, and two different types of mapping. So we combine everything, and it gives us 8 versions of the rolling menu. And then we decided to explore these 8 versions in a 2-step process. First, with a simple toolbar, with the idea to keep the best ones, and then we will try the best combinations with the more complex toolbars. So for both studies, the baseline was the mouse, and with the mouse, the task was to do something similar to what you saw at the beginning of the presentation, to do a movement from the area of interest to the command selected and then come back. And we had 16 and 12 participants. So the input apparatus, so our device, the Roly-Poly Mouse, contains an IMU that is used to detect the roll direction and amplitude, and we use an underlying touch surface, a Wacom tablet, to detect the tap. So here is the example. Basically, it's the same video that you already saw before of a user selecting targets on a simple toolbar. So a very brief summary of the results. All our menus were faster than the mouse, and this is normal if you think that we are removing half of the movement of the selection. However, 3 of our rolling menus were emerged as being better than the others. They were 25% faster than the mouse, and they had a good accuracy over 90%. And what is interesting is that these 3 best rolling menus correspond to these 2 combinations. The direct range works best with tap validation, while the 180 range works best with the roll validation, which is also something that makes some sense, as roll is a less precise gesture and you need to have more room for each sector. So we kept with these 3 these best combinations, and we studied them on the dropdown and grid toolbar. So here you have the example of a dropdown toolbar. So as soon as you select the top level item, you have a drop-down list, and rolling allows you to select the item on the drop-down list. Okay, you get it? And the second was the grid toolbar. So here we have a 3x3 grid. And so the same, we select the first top level item. And then you're going to see we use a translation because we discovered during our pretest that it was difficult to perform a roll in this case, because sometimes the roll direction of the sub-item was going to, depending on the roll direction of the first top level item, it was going to be difficult to perform. So, Okay, so I'm just going to finish with. So the results is that, again, our menus are faster. However, they work better for the drop-down toolbar, where we had a very good accuracy. I think it was 94%, but not that good with the grid toolbar, this one. Probably because of this changing from a roll to a translation gesture. So we still have to investigate into why it didn't work so well for the grid toolbar. And concerning the perspectives of our work, so far as you saw, we explored 3 types of toolbars, but they don't really correspond to the types of toolbars that you may have in a very complex application, such as PowerPoint or Microsoft Word, where you have much more items. The distribution of the items is not necessarily linear, and they are multiple levels on the items. So we want to study how this will work on a more realistic toolbar. And the second thing that we would like to do is to add a validation mechanism on the device itself, because here we were using the underlying touch surface, but it would be better if we had a button on the device itself. But it's something that has both technical, also usability or human-related challenges, since it's difficult to put a button on a round or hemispherical device that can always be reached without changing too much the grip and making it awkward or uncomfortable to use. So with this, I thank you for your attention, and I'll be happy to answer any questions.
Hi, Marco, Jean-Vadedonc from UCL Belgium. Congrats for the work. I was wondering to what extent we could generalize your approach for edge menus, where you have toolbars on the top, on the bottom, on the left, on the right. And my second question, it looks like in your experiment, all the targets have the same size.
Yeah.
To what extent we could generalize for targets of different sizes?
Yeah, so this, I start with the last question. Yeah, when I said to more realistic toolbars, yeah, obviously we include also the fact that targets not necessarily have the same size.
But then the sector would have the same size as well.
Sorry?
Even if the targets have different sizes, would you assume that the sectors have the same size?
Well, it depends on the type of mapping that we do. So there is this direct one. Probably it wouldn't work so well because obviously, again, we will have a problem with targets not having the same difficulty or easiness to be selected. But if we use the one where we kind of force all sectors to have the same size, then I imagine it will work. It will be. Then the question will be, will users understand the gesture that they have to perform to select the item? I think that's more about the mental model of the selection. Concerning the toolbars on the sides, I think we will need to do all the studies that we did because I think it's mostly a physiological problem. So we were studying rolls forward and backward, but then as soon as you're doing rolls on either sides, you start asking for different rotations of the wrist, and probably you don't have the same degrees of freedom, or you don't have the same easiness to perform all the gestures.
Unless you enter some mode, like for instance, you first issue a first gesture to identify which edge you want to target, and then you have to roll again.
Sorry?
For instance, if you roll left, top, or right, in order to identify which edge menu you want to activate, and then rolling again according to your
that could be a solution, right?
But then there are different directions.
Yeah.
Okay, thanks.
Something to study. Thank you.
Hi, Tan from Human Media Lab. So thank you for the work. Have you ever considered to compare your menu to a Mac menu, either like performed by a stylus or a mouse?
To a Mac menu? You said?
Yeah.
Like the one with a...
Yeah, you draw and then select the menu items with your stylus or mouse.
No, that's not something that we thought about, but that's it's an interesting idea.
Yeah.
Something to explore.
I just want to know because they kind of comparable.
No, I don't think so. I mean, but are you talking about the toolbars in the?
Yeah, like they work for any kind of menu, including toolbar, I think.
So the thing with the Mac menu is that you have an empty space. It's not necessarily distributed along all the display. That's one difficulty, obviously. Other than that, it will work probably. But in our work, the toolbar use all the width of the window.
Oh, I see.
But if you see in Mac, you have kind of menus on the left and then on the right with the gap in the middle. So again, this comes with this idea of what happens if the distribution of the targets is not homogeneous, or if they have different sizes and all that. No.
Oh, yeah, so I want to ask what's the minimum degree so the user still feel it's good to interact with your menu?
The degrees are, you mean the role?
Yeah, to row.
So-
The smallest degree between each options.
Okay, I don't have this number right now. Concerning the roll forward or backward, like our previous studies, we show that when you are translating the device, you're usually not rolling the device beyond 12 degrees. So that's why we took 12 degrees as the activation threshold. Then considering the sectors, I don't know, I will have to look into the paper to see.
Thank you.
Thank you.
All right, let's thank our speaker.